Now let's look at some more examples from 5.3. I'm going to try to match up these examples with problems from the assignment. So this first one is like number 7, and we want to find the zeros and their multiplicity. To find zeros, we are going to set the function equal to 0 and solve for x. All right, and remember, if we get real zeros, those are x-intercepts. So let's take our function, 2x times 9x to the 4th minus 12x cubed plus 4x squared. And we're going to set that equal to 0. Now let's factor what we have in those parentheses. So the 2x is going to come along, and we're actually going to factor out a greatest common factor. So our greatest common factor is an x squared. So we can bring out an x squared, and then we'll be left with 9x squared minus 12x plus 4, and that's equal to 0. All right, so the 2x times x squared out in front, we can combine that and just write that as 2x cubed. All right, now we want to factor this quadratic that we have in the parentheses, and we're actually going to be able to write that in 2 linear factors. So we're just going to play around with what's going to work. We know that 3x times 3x would get us to that 9x squared. And we know that 2 times 2 would get us that 4. That's the constant. Now, the middle term is negative, so let's put a negative in front of the 2's. Let's just kind of test out if that gets us back. So we'll use FOIL and see if that gets us back to that quadratic. So 3x times 3x would get us that 9 squared. And then if we do a minus 2x, a minus 2 times 3x, we get a minus 6x. And then a 3x times a negative 2, we get a negative 6x. And then finally, negative 2 times negative 2, we get a plus 4. All right, combining those middle terms, we get 9x squared minus 12x plus 4. Okay, so that checks out. So our factored form is 2x cubed times 3x minus 2 times 3x minus 2 equals 0. Now notice that the 3x minus 2 repeats, so we can write this as 2x cubed as that factor 3x minus 2 squared. Okay, so we have it factored. We now, to find our zeros, we're going to set those factors equal to 0. And we're going to end up with x equals 0. And here we add the 2 to both sides, divide both sides by 3, we get x equals 2/3. Okay, so we found our zeros. We have x equals 0 and we have x equals 2/3. We also want to find the multiplicity. So remember, the multiplicity is the exponent on the factor that the 0 came from. So for the 0 of 0, our exponent is 3, so that gives us a multiplicity of 3. And for x equal to 2/3, our exponent on the factor was 2, so we get multiplicity of 2. All right, here is an example, 2 examples. These are like number 10 and 11. And this first one, well, what we want to do is we want to use the graph to identify zeros and multiplicity. So just like what we did in the previous example, but this time we have a graph instead of the actual function. So to find the zeros, we are going to look for the x-intercepts, okay? So when it says to find the x-intercepts looking at a graph, I'm sorry, when it says to find the zeros looking at a graph, we're looking for x-intercepts. So we have an x-intercept at -3. We have an x-intercept at -1. And we have an x-intercept at 2. So those are the 3 x-intercepts. Now let's find the multiplicity. So here's a reminder about multiplicity. If we have even multiplicity, that means the graph touches the x-axis and has a turning point. And if we've got odd multiplicity, the graph crosses the x-axis. So we can tell if we've got even or odd based on what's happening with the graph at the x-intercept. At x equal to -3, all right, we can see that it definitely crosses the x-axis. So we know that we have odd multiplicity. And we're going to assume that the multiplicity is the smallest possible odd multiplicity, which would be 1. At x equals 1, it also crosses. And we assume the smallest possible multiplicity, which would be 1. But at x equal to 2, it touches and has a turning point. So that means it's even. And we assume the smallest possible even multiplicity, that's 2. And here's another example. Again, we want to find x-intercepts and their multiplicity. So actually, we're asked to find the zeros. But with the graph, we find that by looking at x-intercepts. So here are x-intercepts. So we have x equals -5, x equals -1, and x equals 3. And we're looking whether the graph touches or crosses. So at x equal -5, it crosses. So that implies odd multiplicity. If we look at the smallest possible odd multiplicity, it's 1. For x equal to -1, it touches. There's a turning point there. So that's even. Smallest possible even multiplicity is 2. And at 3, we also have even multiplicity because it touches, so we get multiplicity of 2. Okay, next example is we want to use this graph to write a polynomial function in the least degree. This is like number 9. So the first step to doing this is we want to identify the zeros or identify the x-intercepts. And we also want to find the multiplicity. So let's do that. Find x equals -3, x equals 2, and x equals 5. And then let's write down multiplicity for each of those. So for -3, it's an odd multiplicity because it crosses. We're going to assume the smallest. And for 2, it touches and has a turning point. So it's even, and we'll assume the smallest, even, which is 2. And then 5, again, it crosses, it's odd, so we're going to assume 1. Okay, second step is to write down factors that those x-intercepts with those multiplicities come from. Okay, so for x equal to -3, the factor is x plus 3. Right? If we were to set x plus 3 equal to 0 and solve for x, that would give us -3. So going backwards, we get x plus 3. And it has multiplicity of 1. All right, so we don't really have to put that up there, but that's what it would be. And for x equal to 2, the factor is x minus 2. Right? If we set that equal to 0 and solve for x, we would get 2. Multiplicity is 2, so we put that exponent of 2 on there. And then x equals 5, that comes from the factor x minus 5. And again, we have multiplicity of 1, which we don't really need to put there. Okay, this gives us the function or a start to the function. So we can write down, this is f of x equals. Now, what we don't know is there might be some multiplier out in front. We're just going to call that a. Okay, so the The last thing we need to do here is solve for what that a might be. And we're going to do that by using the y-intercept. Okay, the y-intercept is -2. So that means, let me just identify that. Y-intercept is -2. So what that means is that f of 0, if we evaluate that function at 0, the result is -2. So that's what we're going to do. We are going to plug in 0 for x. A stays A. That's what we're going to solve for. But everywhere we have an x, we plug in a 0. And then we know that that is equal to -2 because that's the y-intercept. Okay, so we can just focus on this part right here. And this is what we're going to solve for A. Okay, so we've got this A out in front. And 0 plus 3 is just 3. 0 minus 2 is -2, and then that is squared. And then 0 minus 5 is -5. And that all equals -2. Okay, so we have A times 3 times -2 squared is a 4 times -5 equals -2. So that means 3 times 4 times -5 is a -60 times A equals -2. All right, to get A, we're going to divide both sides by 60, -60. So we end up with A equals 2 over 60, -2 over -60, or 1/30. Okay, so now we go back and write our function as f of x equals, we can now replace A with 1/30, and we've got our factors x plus 3, x minus 2 squared, x minus 5. All right, and that is our polynomial of least degree represented by that graph. Okay, this example is like number 12 and 13, and it's really similar to the one we just did. Instead of having a graph, though, we have written out some characteristics of the graph. So we have a degree 5 polynomial, and we are told that we've got roots, or another word for that is zeros or x-intercepts. And first of all, of multiplicity 2 at x equal to -3. So let's go x equals -3, and that corresponds to k of 2. And x equals 1, and that also has multiplicity of 2. And then also a root, or we can also, that's a 0, of multiplicity 1 at x equals 4. So at x equals 4, multiplicity of 1. Okay, so each of those zeros come from a factor. So the factor that x minus 3 comes from is x plus 3. And the multiplicity is 2, so that's going to have exponent of 2. And the 0 of 1 is going to come from the factor of x minus 1. That has multiplicity of 2, so we put exponent of 2. And x equal to 4 has multiplicity of 1, so that's going to come from x minus 4. Okay. So we can start to write the polynomial. It's f of x equal to, remember there's an unknown a out in front, and then we've got x plus 3 squared, x minus 1 squared, x minus 4. Okay, the other piece of information that's given to us is the y-intercept at 0, 6. So that means that f of 0 is equal to 6. Okay, so we can take f of 0, plug 0 into the function where we have an x, so the a stays out in front, and then we have 0 plus 3 squared, 0 minus 1 squared, 0 minus 4, and that is equal to 6. So we have a times 3 squared, which is 9, times negative 1 squared, which is 1, times a negative 4. And that's equal to 6. Okay, well, doing this multiplication here, we're going to get 9 times negative 4, so that's a negative 36a equal to 6. Divide both sides by negative 36. And we get a equals negative 6 over 36, which will reduce to negative 1/6. Okay, we put that a back into our function, so we end up with f of x equals negative 1/6 times x plus 3 squared, x minus 1 squared, x minus 4. All right, and that is our polynomial function with those given characteristics.